Okay, so for section 6.5, we have the percents of increase and decrease. So essentially, lots of things in the world change in their value. If you think about cards, even games, or even your quiz scores, they do change. So it can be helpful to figure out, what is the percent of that change. So to figure that out, we have a nice and easy formula here. It's just the percent that a quantity changes from the original amount. So for the formula, all we have to do is take the new amount, subtract the original, and then divide it by the original amount of whatever we're talking about. Now, since we are talking about percent of change, it can either be an increase or a decrease. So when the original amount increases, the percent of change is, of course, percent of increase. So after we apply the formula, the percent of change will definitely be a positive number. So if you come out with a positive percent, then you know that it was an increase. But if the original amount decreases, again, anytime we have decreasing, we would have a negative value for the percent. Now, even though we end up with a negative value, our final answer should definitely still be written as positive. But the fact that it comes out negative, we just know that it was percent decrease, not increase. So for this first example here, we have the table shows the number of hours you spent last night or spent last weekend. Percent of change in your online time from Saturday to Sunday. So since we're going from Saturday to Sunday, the 4.5 is really our new value. So 4.5 minus 2, and that would be taken over the original hours, which was our Saturday hours of 2. Now, automatically you can see that if we went from 2 to 4.5, we should end up with a percent increase with our final answer. So if we simplify the numerator first, we end up with 2.5 divided by 2, which would give us 1.25. So again, it is positive, so we definitely know that it is an increase, but remember we want the percent. So jump the decimal place and we end up with a 125% increase in our hours online. Okay. So example 2 here, we have the bar graph shows softball players' home run totals, percent change from 2012 to 2013. So again, 2012 is now going to be our original value. So in 2013, we ended up with 20, so we have 20 minus 28 over the original total in 2012 of 28. Now with these values, you can automatically see that we're going to end up with a negative difference in our numerator. So we have negative 8 divided by 20. So when we divide that out, we end up with a negative 0.4. Which again, the second you see that it's negative, you know that you're going to have a decrease. But when we rewrite it, we want to just write it as a positive 20%, but label it as a decrease in home runs. Okay, so there's a difference there. Again, positive is definitely an increase, negative is a decrease. So for these on your own, go ahead and try them out. Now, the first number listed is always going to be considered the original because you're starting for part A here from 10 inches moving to 25. So for the original value, you always want to start with the one that's listed first. Okay, so I'm just going to go through and complete these. Make sure you can pause here and then check your answers after, or you can kind of go along with what I'm doing here. Okay, so this first one here, I ended up with a positive 1.5, so I know it's a 150% increase. Part B, I ended up again with another negative 0.4, so I know it's a 40% decrease. And the last one, again, it's another negative value, so once I change it, I know it's 75% decrease. Okay, so the formula is pretty straightforward. Just make sure you're always taking the new minus the original so you're sure whether it was a percent increase or decrease. Now the last thing is section 6.5 here is we have percent error. So the percent error is just the percent that an estimated quantity differs from the actual amount. You can see here that the formula is very similar, but it just has a different meaning. So we take the amount of error over the actual. So you want the positive difference between the guess and the actual amount. So with the percent increase and decrease, we wanted to always start with the new value to see whether we had that positive or negative difference. But with percent error, you always want to keep it positive because you're not going to want to have like a negative percent error. That's not really the context here anymore. We're just trying to figure out like how far away were you from the actual amount. So for example 3, we have Zach estimated the length of our classroom is 16 feet, but the actual length is 21. So how you want to set these up is you want to just get your error calculation, and then you want to just compare it to the actual amount. Now, if you separate the information, you won't kind of lose like which number is which. So for the error, we have 21 minus 16 because we want the positive difference. So that's a difference of 5, and then it was said that the actual length was 21. So for the percent error, just take the 5 over the 21, and this one does give you a long decimal, so I'm going to put is about equal to 0.24. If you end up with a long repeating decimal, again, just round it to the nearest hundredth. Okay, so 2 decimal places. So 0.24 we know is 24%. So 24% error, that's really not too bad. Okay, because again, it's still going to be out of 100 as far as our comparisons go. So for the what if, Morgan estimated that the length of the classroom is 23 feet, so who has the greater percent error? Okay, so go ahead and calculate Morgan's, and then we'll see how they compare. Okay, so for Morgan's, I got that she had about a 10% error. Now, whenever I got it in decimal, it was like 0.98 something. So whenever you round, you actually have to round up kind of twice. So I ended up with around 10%. If you did about 9.8%, that's also good. So when we go to compare here, we see that Zach's percent error was 24, but Morgan's was 10. So because Morgan guessed closer to the actual, her percent error, of course, is better because you want the smaller amount of error, because the smaller the error, the closer you were to the actual guess. So for an explanation here, we can say that Morgan's guess was closer to the actual. Okay? So for, again, percent increase and decrease and percent error formula is very similar. You just want to make sure that you're keeping the right context in whatever you're talking about.